In calculus, there are just some derivatives that you have to memorize. These derivatives are so fundamental that it should become automatic like 2 times 2. The derivatives we'll cover today are the trig derivatives, the exponential derivative, and the natural log derivative. The most common type of derivatives that you'll probably be tested on are the trig derivatives. So pause the video and take a minute to write these down. There are a lot of them, but it's honestly not too bad. Here are a couple of tricks to memorizing these derivatives. So first of all, the relationship between sine and cosine. Sine's derivative is cosine. Cosine's derivative is sine. That's pretty straightforward. Another type of pattern that you'll see is that tan's derivative is secant and cotan's derivative is cosecant. So if you keep those tricks in mind, a lot of the memorization becomes pretty simple. A very important thing to notice is that on the derivative side, we have some derivatives that have negatives. And so you might be thinking, oh my goodness, I'm going to get so confused which ones are going to have the negative. There's a really nice trick for this. If we look on the left-hand side, so the original functions, we notice that all the ones with the negative signs, they all start with the letter C. So if you're confused, ask yourself the question, does my original function start with the letter C? Cosine, cosecant, cotangent, they all start with the letter C, and all of their derivatives have a negative sign. The next derivative you have to remember is the exponential derivative. It's my favorite derivative. It's so easy. E to the x. What is the derivative of e to the x? The derivative of e to the x is e to the x. It is the exact same thing. One of the trickiest derivatives to memorize is the natural log, or better known as ln. So what is the derivative of ln of x? The derivative of ln of x is 1 over x. It's a little odd, but again, we just have to commit this to memory. Another thing we might be wondering is, okay, what if we have something like this? Y equals 4 cosine of x. We have a random constant here. What do we do with it? Well, it's pretty simple. All we do is we keep it. Just leave it alone. Don't touch it. So the derivative of y, or y prime, is going to be 4. Just leave the 4. And then we only care about this derivative. So the derivative of cosine of x is negative sine of x. Why? Because it starts with a c. It has a negative. So the final answer will be y prime is equal to negative 4 sine x. Again, we don't touch constants. So if we have something like f of x is equal to 8 e to the x, we notice that 8 is just a constant. We leave it alone. Just keep it as 8. And then we take the derivative of, oh, it's e to the x. Okay, e to the x is e to the x. So the final answer is f prime of x is equal to 8 e to the x. So what do we do if we add or subtract a bunch of these? Let's say we have an example like y is equal to 8 e to the x minus 2 tan x plus 4 ln of x. What do? All we do is we take the derivative of each one separately. So let's do it. The first one, 8 e to the x. The 8 is a constant, so we just keep it. And then the derivative of e to the x, my favorite, e to the x. And then minus. Then we take this derivative. So we notice that 2 is a constant, so we just drop the 2 down. And then the derivative of tan x, if you remember, is secant squared x. Alright, last one. So the derivative of 4 ln of x. 4 is a constant, we just drop the 4. And then we take the derivative of ln, and if you remember, the derivative of ln is 1 over x. So our final answer is going to be y prime is equal to 8 e to the x minus 2 secant squared x plus 4 over x. Here is a final problem that you should try on your own. Pause the video now and do it. Okay, and if you're back, we'll do it together. Again, addition, subtraction, it doesn't matter. We just take the derivative of each one separately. So let's do it one at a time. So the first one, 2 tan x. The 2 comes down, and the derivative of tan x is secant squared x. So secant squared x. Alright, the next one, we have a minus. Then the derivative of cosecant x, what is it? Cosecant x is negative cosecant x cotan x. Then minus. Alright, next one. The 4 is a constant, so we just keep the 4. And then the derivative of e to the x, my favorite, e to the x. Perfect. And the last one, ln of x. What do? It's over 2. Well, not to worry, because ln of x over 2 is actually just half ln of x. This is a common trick. Try to pull out denominators if you can. Alright, so half ln x, same thing. We just take the constant, drop it down, so it's half. And the derivative of ln of x is 1 over x. Alright, great. So our final answer is f prime of x is equal to 2 secant squared x. The negatives become a positive, so we get plus cosecant x cotan x minus 4 e to the x, and then plus, we can simplify this to 1 over 2x.